Welcome to a lesson with Dr. Pal. Let's take a look at an example of block matrix multiplication by using column partitioning on the first matrix. So just a simple partition like these two, then those two, but we use the same partition for the rows on the next one. Okay, now when we matrix multiply, all we simply do is take this matrix times that one, plus this one times that one. So like over this one times that one, then this one times that one. So first to first, second to second, going along this way, and then down that way in the partition. Okay, so how do we multiply this guy and this guy together? Well, I'm going to use the column interpretation the whole way. What does this mean? This means take 1 times this column plus 1 times that column. So basically, 1, 1 means add the columns together. So we can add these two columns together, and we end up getting 0, 1. This one means add those columns together again, so we get the same result. Here, this means pick out the last column right there, negative 1, 1. All right, so we just matrix multiplied this and this. Now, what we do is we add to this what we get by matrix multiplying this and this. So what does this mean? That means pick out the second guy, which is in here, is set 0, 1. This means add those two together. So that would be 1, 2. This means take the negative of that column right there, so 0, negative 1. Now we can add these together. So adding, just adding component-wise, or I'll just add column to column here, we end up getting 0, 2. Here we get 1, 3, and here we get negative 1, 0. And this is the result. Now this result should work no matter which partition we use of the columns to the rows right here. So we could try yet another one and see if we obtain the same thing. Okay, so let's try that and see what we can do. Well, let's try a partition like this. All right, let's do that one right there, the same partition. So let's take this times this. Now, what is this? This is like, so right here we see 1 is going to be input into here, and the output's going to be in R2. But it's fairly simple for this column right here. The image is simply just 1 times that column, so it's just 1, 0. So we get a 1, 0 for that guy, and then we have okay, and then we get this guy right here with that column, and the same thing, 1, 0. So like 1 times that one column, then 0 times that one column is just zeros. All right, so we just did this times this, quite literally, thinking of the input of this as being R of R3 and the output as being R. R goes into here and R2 comes out. So R2 comes out, R3 goes in. It's the right size. And quite literally for this column, where is this column headed? It's headed to this because it's just 1 times that one column, 1 times that one column, 0 times that one column. So it's pretty simple to multiply if you just had a single row right here to a matrix that looks like that. That's not too bad. Okay, then we add, let's see, we have this middle matrix times that one. So let's see, what is the first column of the result? The first column is going to be, well, it's just 1 times that column plus 0 times that column, right? So it's basically just that column right there, negative 1, 1. Okay, now the next one is going to be just add the two together. So 0, 2. And this one is simply going to be negative 1, 1. Okay, so that's the result from the middles. Now we get this times that. So we think it's the same idea that we had here. It's simply 1 times that, so just 0, 1. 1 times that again, 0, 1, and negative 1 times that, so 0, negative 1. So then we just add these results together. So we end up getting, okay, so we will end up getting across on the top, just adding these two rows right here together, we end up getting a 0, and then a 1, and a -1 on the top, looks like. And then the bottom looks like we're just adding these two guys because we have zeros over there. So we end up getting a 3. No, so sorry, 2. It's just getting a little ahead of myself. 1 and 1 is a 2, and 2 and 1 is 3, and 1 and -1 is 0. So we end up getting the exact same result right here. So using any partition, we can get of these columns and use the exact same partition of these rows. We just add the results of the matrix calculations for each one. We will always end up getting the same thing. Thanks for watching.